Okay, so this is just the very end of the circle. This is the handout you already have. So we're just basically finishing that, and that's the end of the circle. So I'm also going to attach some questions with solutions on this. Well, it's not just this, actually, it's questions on the circle. So you can kind of practice them and look at the solution, or, go over the solutions and see, just for a little bit more practice. Okay, so circles touching the axes. So just to explain this, it says, well, if the circle's touching the x-axis, g squared is equal to c. Now, why is that? So let's think about just coordinates, like normal coordinates. So let's say the center of the circle was at 5, 8. What we would do is we would go over 5 and we would go up 8. So we'd say the center is there. Now, if you think about that, if my center, now remember, this has to actually touch the axis, in this case, the x-axis. So if the circle is touching the x-axis, very bad circle, does it make sense that the amount that I've actually gone up is the significant one? So I said 5, 8. So it's the 8 that is the radius. Does that make sense? So I'm going over 5 and up 8, but it's the 8 that's the radius. So when we go to do more of an abstract one, all circles have center minus g minus f. Now, again, that minus g minus f is an absolute value. Like minus g doesn't mean that it can't be in the first quadrant. So like g might be -2, so it might be minus -2, which is 2. I'll explain that a little bit more in the calculation in a sec, but hopefully you understand that because the center of the circle is minus g minus f, just like over here, it's the second number that's the radius. So it's the second number that's the radius. Now, technically that's minus f, but it's the absolute value of minus f because a radius can't be negative. It's a distance, so the smallest it can be is 0. So what I've written is that the radius is equal to the absolute value of minus f. So in other words, the radius is equal to the second part of the coordinate, just like over here, the second part of the coordinate was 8 and the radius was 8. So because it's minus f, the radius is equal to the absolute value of minus f. So the formula for radius is g squared plus f squared minus c is equal to the square root of that is equal to the absolute value of f. Now we're going to square both sides to get rid of the square root, or you can think of it as moving the root to the other side becomes squared. Either way, you end up with this sentence here. The f's cancel, and that's what leaves us with the fact that g squared is equal to c. Now, the advantage of that is when you go to fill in information to get the equation of circles, normally we're trying to find f, g, and c, but because c is equal to g squared, it cuts down on the work. So in other words, really, if we know that a circle is touching an axis, it actually makes the question easier for us. If you didn't want to remember all of that, another way to think of it is, like I often think x-axis, so when I hear x-axis, I think first coordinate, which makes me think of g, first part of the coordinate, and then I write g squared is equal to c. That's kind of like just like a little shortcut. When we go to do the y-axis, when I think y-axis, I think second part of the coordinate, which is f, and therefore f squared is equal to c, if that makes sense. The proof itself is exactly the same. You say the radius is equal to the absolute value of minus g. You do the same thing, you square this side, the g's cancel this time, and that's why you end up with f squared is equal to c. Now, what happens if it's touching both x and y axis? Well, this is better news again. It turns out that g squared and f squared both equal to c, which makes the question easier again, because if you figure out what c is, then you automatically know what g is and what f is. or vice versa. If you know what G is, you'll automatically know what F is and what C is. So really, if the circle touches off any of the axes, it actually makes the question easier. So let's say we're doing this question. Find the equations of two circles. Now it's two circles, so we're expecting some sort of a quadratic here. I mean, I can't get two values unless it's quadratic, so that's a kind of a hint there. Now we're told that the circles contain the point 3 minus 2, 2 minus 1, and it touches the x-axis. Now, what do we normally do? So like on that last lesson before Christmas, what we would normally do is we would use the general form of a circle. So x squared plus y squared plus 2gx plus 2fy plus c equals 0. And what we would do is we would normally fill in. So I'd fill in the 3 there, I'd fill in the minus 2 there, and all the ways across, I would be doing that. So then I get 9 and 4 and 6 minus 4 plus c equals 0. So I'd end up with 6g minus 4f plus c is equal to, now 9 and 4 is 13 minus 13. Now that's one of them. I would do the exact same then with the other one. So I'd fill 2 in there and I'd fill the minus 1 in there. And working my way across, replacing the x. And now actually for anyone, unfortunately, it's not. So yeah, there was nothing we could do about that. It just wasn't working. So I did the calculations on the board. Now, these are simultaneous equations. There's one more thing I know, and it touches the x-axis. Now, when I think x-axis, I think g, as in the first coordinate of the center, minus g minus f. So I think of g. So g squared is equal to c. So that's something I know. Now, if you've forgotten, you just go back up here and check that when it touches the x-axis, yes, g squared is equal to c. So that's something I'm going to make use of in a moment. But before I do any more, I'm going to cancel out, I think I'm going to cancel out the f's. Now, the reason I'm doing that is because if you think about it, there's a connection between g and c. So if I could somehow get rid of the f's, that would leave me with g and c. And then couldn't I replace the c with g? And then I'd have an equation all in g. So I hope that makes sense why I'm going down that route. So I'm going to line up one underneath the other. Now, again, in the last lesson, we did loads of questions on simultaneous like this. So all of this should look familiar, hopefully. So what I'm going to do is multiply the bottom by minus 2 to get the f's to cancel. So I'm going to multiply minus 2. That's minus 8g plus 4f minus 2c is equal to 10. The f's cancel, and I'm left with minus 2g minus 1c is equal to minus 3. Now, this is good news because I can now replace c with g squared. Now, remember I said to you I was expecting a quadratic because of the fact that it was two circles. So this explains now how the quadratic has come into play. Now, so we're happy about this situation. So I might put everything on the right just to get rid of the negatives there. Minus 3. So what I'm going to do now is just my usual factorize. I can use my minus b formula to solve, or I can do the null factor theorem. I'm going to just do the null factor because I suppose it's not that tricky. So it's going to be 3 and 1. So I'm going to do 3. So 3 times 1 makes 3. But the signs are opposite because that's negative. So that makes this the 1 and that makes the 2, which make, oh, sorry, what am I doing with the g? Sorry. Should be no g in there, just 1. So I've now discovered that g is either minus 3 or g is 1. Now that means then we can figure out c. So g squared, so there are two values. G squared is equal to c. So that automatically means when it's minus 3, c is 9. And when it's 1, c is 1. So I've now figured out that c is 9 and 1. Regarding f, well, I'll have to go back up to the one of the initial sentences. So I'm going to go back up, for example, to this one. Any of them will do. And in the place of g, I'm putting minus 3, minus 2f. And obviously, I need to use the correct c. So, you know, it's the two of these match up. And then I work that out to get my F. So what's that going to be? So that's going to be, I think I'll actually put everything on this side and move over the two F's. So that's, what's that? That's 14 minus, that's 2. So F is 1. F is 1. And then if I do it again, but this time I fill in my 1 in the place of G, and in the place of C, I put 1. I end up getting 4 plus 1 plus 5 is equal to 2F, 9, 10. So in this case, F is 5. Now, all I have to do then is fill in my two gx plus 2 fy plus c. And then I just fill in my values. So if G is minus 3, F is 1, and C is 9 in that scenario. And then I do exactly the same for the other one. Now, obviously, I should be working that out, but I'm just conscious of the time here, because if the video goes too long, I will not be able to put it up on YouTube. So all I'm doing is filling in the G and the F and the C for each one, and then multiply it out, and you get your two answers, and they're your two answers once you multiply them out.